Hello dear friends, welcome back to my channel. In this video I am going to discuss with you common viva questions that can be asked during practical exam of kinetics. I dedicate this video to all my students whose performance in the practical exam has inspired me to make such series where I'll discuss with you all viva questions which are asked commonly during the practical exam. Another reason is that when a video is shared with you, you can watch it at your own time, you can rewind it, you can pause it, you can review it again and again, you can watch it again, which is not possible during a class. That's why I'm sharing this video with you. So without wasting time, let us discuss some common viva questions that are asked whenever you are doing kinetics experiment in practical exam. The first question is, what is chemical kinetics? Chemical kinetics is that branch of chemistry which deals with the study of rates of reaction and their mechanisms. So it is branch of chemistry, and what you study in that is the rate of reactions and its mechanisms. What do you understand by the rate of reaction? The answer to this is the rate of reaction is defined as the change in the molar concentration of any one of the reactant or product per unit time. So with respect to time, how much is the change in the concentration of reactant or product is called as the rate of reaction. In simple words, the rate of the reaction is the speed of the reaction. The third question is, what are the units of rate of reaction? The units of rate of reaction is mole per liter per second. The fourth question is, what are the factors on which the rate of reaction depends? So the rate of reaction depends upon various factors like the nature of the reactants, concentration of the reactants, temperature, presence of catalyst, and presence of radiation. So remember these 5 factors on which the rate of reaction depends. The fifth question which can be asked to you is, what is the law of mass action? The law of mass action states that the rate of a reaction is directly proportional to the product of molar concentration of the reactants. This is law of mass action. Sixth question is, what is temperature coefficient of a reaction? Temperature coefficient of a reaction is the ratio of rate constant at two different temperatures varying by 10 degrees. Its value is generally equal to 2. It means that when you increase the temperature, the rate of the reaction increases. And how much does it increase? How much does it increase? It increases double. Okay, so when the temperature is increased by 10 degrees, the rate of reaction doubles. This is what you have to remember. We move on to the next question. Question number 7. What are the units of rate constant for zero order reaction? So for zero order reaction, the units are same as the rate of reaction, which means moles per liter per second. Another question is, what is zero order reaction? This is very basic question. So zero order reactions are the reactions in which the rate of the reaction does not depend on any of the reactants. Order means what? Order means on how many reactants the rate of reaction is dependent. Okay, so in zero order reaction, the rate of the reaction does not depend on any of the reactants. So what about first order reaction? In first order reaction, the rate of the reaction depends on the concentration of only one reactant. May two be there, but the rate will depend only on one reactant. So other may be to a very high amount like water, so its concentration will not matter much. And same way, second order reaction would be a reaction where the rate of reaction depends on the concentration of two reactants. We'll move on to the next question. Question number 8. What are the units of rate constant for first order reaction? The answer is per second. Next, question number 9. What is the effect of temperature on rate constant of a reaction? So you should know that the rate constant increases with increase in temperature. And how much does it increase? I've already told you, when you increase the temperature by 10 degrees, the rate constant doubles. We'll move on to the next question, question number 10. Why certain reactions are very fast? So the answer to this is because they have very low activation energy. So I hope you remember, students, in your lower standard you have studied about activation energy. So if here is your reactant, this is an energy barrier they have to cross to become product. This is your product. So the distance here till here, this distance is called as activation energy. This is the activated species which are present here, and here are the reactants. So this distance is called as activation energy, and lower the activation energy, fast would be the reaction. Question number 11 is, what is threshold energy? The answer to this is, it is the minimum energy which the colloiding molecules must possess so as to have effective collision. The next question is, why reactions with molecularity more than 3 are rare? Now we consider, according to collision theory, we say that a reaction will occur when two molecules collide. Okay, so a molecularity more than 3 means 3 molecules are going to collide at the same time, and which is a very rare situation. Okay, so because simultaneous collision between more than 3 particles is rare on the basis of probability considerations. This is because of this, the reactions with molecularity more than 3 is very rare. Next question is question number 13. For an exothermic reaction, activation energy for the forward reaction is less than that for the backward reaction. Is this statement true or false? The answer is yes, this statement is true. For exothermic reactions are the reactions where there is liberation of heat. Heat is lost from the system. So for these, the activation energy for the forward reaction is less than that of the backward reaction. So it's very easy for the reaction to go in the forward direction than to come back. The next question is, what is rate determining step? The rate determining step is the slowest step in the reaction. Okay, so the slowest step is called as the rate determining step. Question number 15. What is the effect of catalyst on the activation energy and heat of the reaction? So the answer is, a catalyst decreases the activation energy of the reaction. It has no effect on the heat of reaction. So you have to remember the role of catalyst. It decreases the activation energy, but it has no role on heat of reaction. Question number 15. On increasing concentration of reactants, the rate of the reaction does not change. What can you say about the order of the reaction? So on increasing the concentration of the reactants, the rate of reaction has not changed. Can you guess what can be the answer? The answer is, it is a zero order reaction. That is why the concentration of the reactants is not affecting the rate of the reaction. We'll move on to the next question, question number 17. Can order of a reaction be fractional? The answer is yes. For example, this is a reaction in front of you, CH3CHO, giving you CH4 plus CO, methane, plus carbon monoxide. The order of the reaction is 3/2. So yes, the order of the reaction can be fractional. The next question which can be asked to you by the examiner is, What is a complex reaction? So the answer is a reaction involving more than one step is called as a complex reaction. Question number 19 is why ice is added in kinetics experiments. So if you have observed in all the kinetics experiment you use ice. Now why ice is added? It is added to stop or to arrest the reaction. Why do you want to stop the reaction? You want to stop the reaction because you are taking readings at a particular time. So suppose you want to take reading at 5 minutes. So you stop the reaction at 5 minutes and take the reading. You stop the reaction at 10 minutes and take the reading. You stop the reaction at 15 minutes and take the reading. If you do not stop the reaction will go on and you will not be able to take the reading. This is why we add ice to the reaction mixture during kinetics experiment. The last question is what happens to the burette readings with time? Very favorite question of the examiner, and the answer to this is you have to check your manual. This is because for different type of kinetics the answer would be different. For many kinetics experiments the burette reading increases with time, and for some kinetics experiment the burette reading decreases with time. And why does this happen? This also would be mentioned somewhere in your manual as theory. So read that particular theory and go for the exam. And this is all from my sides. I hope you have understood the video. If you have, then do like, share and subscribe. Also in the comment, you please write down if any other question you have in your mind. Thank you so much for watching.